Hello friends, welcome to Chemistry Art. I am Bhavik Kumar Patel. So friends, today we will discuss about hybridization. I will try to explain you hybridization, what is hybridization, how hybridization takes place, and what are the requirements and how we can understand the valence bond theory with the help of hybridization. Mainly this hybridization helps to understand the shapes of the molecules. Okay, so the main thing is you need to understand first of all what are orbitals, what is covalent bond, how the atoms are combining. So there are so many terms you need to understand about it before understanding the hybridization. So let me tell you first, in an atom a nucleus is there. Okay, so surrounding of this nucleus, the region where the probability of finding an electron is maximum, that region is called orbital. Okay, and these orbitals are different. Okay, so s orbital, p orbital, which is having dumbbell shape, then d orbital, f orbital, different orbitals are present. The s orbital is spherical shape, p is dumbbell, d is double dumbbell shape. Okay, so like this there are orbitals in which we can say that it is the region of electron where we can find out the electrons. Now why we need to understand about the orbital? Because hybridization is nothing but it is the mixing of two different orbitals but having the very less energy difference. Okay, so for that I told you need to understand about the orbitals, and then after the second point you need to understand about the covalent bond. What do you mean by covalent bond? We know that there are some bonds, for example covalent bond, ionic bond, metallic bond. But what is covalent bond? Because hybridization always takes place in covalent bond, to form covalent bond. So covalent bond is nothing but it's a bond which is formed by two different atoms by mutual sharing of electron. For example, this electron is of this A atom, okay, and another this electron is of this B atom, and if they want to complete their octet, they are sharing their one electron, mutual electron, and they are forming the bond. It is called covalent bond. So in covalent bond the mutual electrons are shared between two atoms. Okay, and how the covalent bond is actually formed? So the covalent bond is formed by overlapping of the atomic orbitals. Means suppose this is atom A and this is its orbital, for example it is s orbital. This is atom B and this is the atomic orbital of B atom, and when the A and B are combined they are forming a bond, a covalent bond. It means that their orbitals are overlapping, intermixing with each other. Now there are two types of bonds. Okay, so in covalent bond there are two types. One is sigma bond and another is the pi bond. Sigma bond and pi bond. So these types are totally depends on the types of overlapping. If orbitals are overlapping like this, this is one orbital, this is another orbital. If the overlapping is happening like this, intermixing means totally intermixed with in each other. Okay, then it is called, then the bond which is formed is called sigma bond. We can also say it's end-to-end overlapping. For example, the two s orbitals, for example this A and B, their orbitals are overlapping. So this is A atom, this is B atom, and these are the orbitals, and this overlapping is end-to-end or complete overlapping, or we can also say axial overlapping, and it is forming a sigma bond, which is stronger bond. Now the strength of this bond is depend how much overlapping is taking place. Then the pi bond. This sigma bond can be formed between the two p orbital also. This is p orbital, this is another p orbital, and you can see here overlapping is taking place, and this overlapping is also called end-to-end overlapping. Again, if you have this is p, it was s orbital. If the overlapping is happening between the s orbital and p orbital, so it may be like this. Okay, whatever, if the overlapping is complete overlapping, end-to-end overlapping, it is forming a sigma bond. And what is pi bond? So if the overlapping is like this, if the overlapping is not end-to-end, parallel overlapping, for example, two p orbitals, okay, two p orbitals. If two p orbitals are overlapped side to side, not intermixing, okay, not end to end, side to side overlapping is taking place, then this kind of bond is called pi bond. So these all the things you need to understand before understanding the hybridization, because hybridization is nothing but it is the formation of orbitals before the bond formation, before the covalent bond formation. So when this hybridization takes place, if you want to understand, before it you need to understand what is orbital, what is covalent bond, what is sigma bond, what is pi bond, all the things you need to understand. Now I think you understood that what is sigma bond and what is pi bond. Now for example, if we want to form a bond between two hydrogen atoms, okay, these are two hydrogen atoms, they have their own 1 electrons in their atomic orbital. Now when hydrogen atoms are forming hydrogen molecules, so there are two electrons are combined like this. Their two s orbitals are combined and the two electrons are shared between two atoms, and it is the formation of hydrogen molecule. Okay, so hydrogen molecule is formed like this. Just like that, in another molecules so many covalent bonds are forming, but today we need to understand what is hybridization. So when an atom is trying to complete its octet, okay, so they are trying to complete their octets by forming a covalent bond or ionic bond. But we are discussing about the covalent bond, we want to discuss about the hybridization. It means here we will discuss about the covalent bonds. So for example, hydrogen need one electron, that's why it connected or it had formed a bond with another hydrogen and octet is completed. Octet means here in case of hydrogen we will consider it as a 2 electrons. Okay, but for another molecules like water, H2O, hydrogen and 2 hydrogen are forming a bond with oxygen. For example, this 2 electron pair which are known as a lone pair of electrons are of oxygen, and one electron is shared with hydrogen. These 2 cross are the electrons of hydrogen. So here you can see that hydrogen is sharing 1 electron with oxygen. Oxygen is also sharing with this hydrogen 1 electron, and just like that the another thing is, now total number of electrons of oxygen are 1 2 3 4 5 6 7 8. So like this they are forming a bond, and the shape of water molecule is like this, it's a band shape, and you can understand how and why this shape is by VSEPR theory. But VSEPR theory is not giving all the information about the shapes of molecule, and that is why again I am coming to the main point, hybridization. Okay, so when and how hybridization takes place. So first let me tell you, suppose we have beryllium, boron, carbon. So atomic number of this beryllium is, what is the atomic number of beryllium? It is Yes, do you know that? You need to remember it. Okay. The atomic number of beryllium is 4. Boron is 5. Carbon is 6. If we write the electronic configuration of beryllium, it can be written as a 1s2, 2 electron in first atomic orbital, s orbital, and 2s2. It means that 2 electrons are filled. In boron, electronic configuration is 1s2, 2s2, 2p1. It means in s orbital 2 electron, but in p orbital 1 electron is there. In case of carbon, 1s2, 2s2, and 2p2. So if we discuss about the formation of covalent bond, it means we can consider that in beryllium the valency is, or we can say there is no any valency in s orbit, because s orbital's capacity is of 2 electrons and 2 electrons are already filled, so 0 valence. Okay, in boron we can say that p orbital, and that is a px1. So one p can form a bond with another one to couple, to make pair, like, and in carbon we can say that covalency is 2, but it is not like that. Okay, so what happens? Just let's take example of carbon. Carbon's electronic configuration we can write, its atomic number is 6, 1s2, 2s2, and 2p2. This electronic configuration is of ground state. Means when carbon is not forming any bond, this is the electronic configuration we can consider of carbon. But when carbon is forming a bond, we need to write it like this. Carbon's electronic configuration in excited state, 1s2, 2s2, 2p2, but from 1s2, 1 electron is going into the 2p, so 2p3 it will be. So this configuration is of excited state electronic configuration. We can write like this: 1s2, 2s2, 2px1, sorry, not 2s2, 2s1, 2py1, and 2pz1. Means here you can see that sp, 3p, and 1s, they have 1 electrons in each. And now the carbon has covalency of 4. The same thing is happening because when beryllium is forming BeF2, here you can see that the covalency of beryllium is 2, where here you can see s orbital is already fulfilled. So how it is forming a bond, or how the another electrons can arrange inside of this s orbital? Just like boron. In boron it is also same. If we write the compound formed by boron is BF3, so here you can see that one boron is forming a bond with 3 fluorine. How it is possible? Because you know that in s orbital only 2 places are there and already it is filled, and p orbital 1 electron is there, so you can fill 1 electron in p orbital, and that's why I already told you that covalency of, as per this electronic configuration of beryllium, is 2, and boron's is 1 and carbon's is 2, because here p, we can consider this is px1, it is 2px1, 2py1, so 2. Okay, but it is not actually like this. The covalency of carbon is 4, and how it is like this? So the main thing is, again, what is hybridization? Here the main thing is the carbon which is having total 1s orbital and 3p orbital, total 4 orbitals in outermost shell, they want to combine with another atom of carbon or any other element. But the main problem is the energy of s orbital and the energy of p orbital is totally different. Totally different means they are not same. The shapes of s orbital and p orbitals are also different. So before forming a bond with any another atom, these 4 orbitals of the carbon will be intermixed and they will form another 4 new orbital which will have same energy and same shape and same size. Okay, and that is called hybridization. So now let's move towards definition of hybridization. See, what is hybridization? So hybridization is defined as mixing of the atomic orbitals. Okay, atomic orbital, for example, as I told you, 1s orbital and 3p orbitals. Okay, 1s and 3p. So total 4 orbitals are taking participation and they will form a new 4 orbitals. Okay, so atomic orbitals belonging to the same atom but having slightly different energies. Carbon's atomic orbitals will intermix. Okay, which orbitals? Which have different energies, so that redistribution of energy takes place between them, resulting in the formation of new orbitals of equal energies and identical shapes. So it means that here when 1s orbital of carbon and 3p orbital of carbon combine to form a hybridized orbital, the new 4 hybridized orbitals are formed and these hybridized orbitals of carbon have shape like this. Okay, like this. Okay, we can just show these orbitals, because when hybridized orbital is forming, the lobes are like this, one bigger and one smaller. Okay, so these are the hybridized orbital of the carbon. Okay, here one. Okay, so this one are sp3 hybridized orbitals. Now if carbon wants to form a bond with another element, like if the carbon is forming CH4 bond, so the hybridized orbitals, sp3 hybridized orbitals, which are like this, carbon's sp3 hybridized orbitals, 1, 2, 3, 4. It is having tetrahedral shape. In VSEPR theory, you can understand this why and how. Okay, so this sp3, 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 all orbitals are sp3 hybridized orbital. These sp3 orbitals will form a bond with another element. For example, if CH4 is forming, so one carbon is forming 4 bond with 4 different atoms of hydrogen. And as we know that hydrogen atom is having s orbital, so atomic orbital of hydrogen is forming covalent bond by overlapping. Okay, overlapping between 1s orbital and this is sp3 hybridized orbital of carbon, 1s orbital of hydrogen and sp3 orbital of carbon. Hydrogen overlapping hydrogen, 1s orbital, all the hydrogen have 1s orbital, and this is how the carbon is forming the 4 bonds with 4 different hydrogen. And this bond formation is happening after hybridization. So in short, I can explain you hybridization is what? Hybridization is nothing but it is the intermixing of atomic orbital of an atom and forming a new orbitals of the same number of orbitals. How many number of orbitals have taken participation? The same number of orbitals will form, but that new orbitals will have same energies and identical shapes, and yes, these orbitals will called as a hybridized orbitals. So here these sp3 hybridized orbitals are forming a bond. If one s orbital and 3 p orbitals are participating, it is forming sp3 hybridized orbital. If one s and 2 p orbitals will participate, then will form, and the orbitals will call as sp2 orbital. And if one s and 1 p is taking participation in hybridization, then the orbitals which will form will call sp. So here 2 are taking participation, here 3, and here 4. Mostly when carbon is forming double bond, so the hybridization is sp2 hybridization. When carbon is forming triple bond, the hybridization of the carbon is sp hybridization. And when carbon is forming 4 single bonds, it is mostly sp3 hybridized orbital which are forming the bond. So here I tried to explain hybridization. If still you have any doubt, you can ask in a comment section. I will try to explain this in more depth. Okay, so you understood or not, I don't know. Please do not skip this video. Okay, please watch full video. Okay, and if you don't understood, please ask me in comment and try to watch it again. And please note down, this is a definition which is very important. And again I'm telling you, short definition is what? Mixing of atomic orbital of an atom and formation of new orbitals which are having same energies. Which orbitals are intermixing? Which are having the different energies. Okay, they will intermix and they will form the same number of orbitals, and it is called hybridization. And it is very important to understand the molecular shapes and to understand the valence bond theory. Thank you very much. Please don't forget to like, share and subscribe. Okay.